Hello and welcome to Tech of the Day. Today we are going to talk about Azure Functions. Implement Azure Functions. This is the fourth module of AZ-203 second chapter. We will talk in this module. We will cover Azure Functions, developing Azure Functions by Visual Studio, implementing durable functions, and there is a lab of building a web application on Azure Platform as a service offerings. But we will do this lab in a separate video, otherwise it will be too big. So let's get started. Today's topics, we already discussed Azure Functions, develop Azure Functions by using Visual Studio, implement durable functions, and the lab. But lab is a separate video, as I said. First, Azure Functions. In this lesson, we will cover Azure Functions, scale and hosting, triggers and bindings, best practices. Azure Function is a solution for easily running small pieces of code or functions in the cloud. You can write just the code you need for the problem at hand without worrying about whole application or just infrastructure to run it. Functions can make development even more productive, and you can use your development language or of your choice such as C#, F#, Node.js, Java or PHP. Pay only for the time your code runs and trust Azure to scale as needed. Azure Functions lets you develop serverless applications on Microsoft Azure. Functions is a great solution for processing data, integrating systems, working with the Internet of Things IoT, and building simple APIs and microservices. Consider functions for tasks such as image or order processing, file maintenance, or any task that you want to run on a schedule. So it's a solution for running small pieces of code or functions in the cloud. Write only code that is relevant to your business. Remove the unnecessary writing of code to connect or host application components. Build an open source web job code. Supports wide variety of programming languages such as C#, Java, PHP, Python, and JavaScript. Node.js even supports scripting languages such as PowerShell and Shell. So, function integration. Azure Function integrates with various Azure and third-party services. These services can trigger your function and start execution, or they can serve as input and output for your code. So you can connect to any input or output service, third-party service, as a result of your Azure function. The services integration which are supported by Azure Functions are Azure Cosmos DB, Azure Event Hubs, Azure Event Grid, Azure Notification Hubs, Azure Service Bus, queues and topics, Azure Storage, blob queues and tables, on-premise using Service Bus, Twilio SMS messages. So you have all these services, third-party services also you can connect with Azure Functions. So for storage, you can have queue, blob, table. With Service Bus, you can use topics and queues. With database, Cosmos DB or other type of databases, event hubs, event grids, notification hubs, and Twilio. So it provides you large type of choices actually. So this simple Java function provides echo functionality by taking into body of HTTP post request as a string and returning the same body as response. So if you see here, you have a function which echo the HTTP trigger name, request and post method, authorization label anonymous, and returns the request with formatting the string, and you can connect this to any output with a simple logic. We don't need to configure more You don't need to write a code to configure the connection. The simple sample Python function is triggered by the creation of new Azure storage blob. When triggered, it logs information about the blob. So when you drop something in the Azure blob, it will just trigger and write down some logging for that. So you can have different type of Azure functions for your application. Scale and hosting. Azure Functions runs in two different modes: consumption plan and Azure App Service Plan. The consumption plan automatically allocates compute power when your code is running. Your app is scaled out when needed to handle the load and scaled down when code is not running. You don't have to pay for idle VMs or reserve capacity in advance. In either plan, an instance of Azure function host executes the function. Consumption plan. In consumption plan, when you are using a consumption plan, instances of Azure function hosts are dynamically added and removed based on number of incoming events. This serverless plan scales automatically and you are charged for the compute resource you only when your functions are running. On a consumption plan, a function execution times out after a configurable period of time. So you can configure period of time. After that, it will go idle and you pay only for the time you consume the resource actually. App service plan. In the dedicated app service plan, your function apps run on dedicated VMs or basic, standard, premium and isolated SKUs, which is the same as other app service apps. Dedicated VMs are allocated to your function app, which means that function host can always running. App service plan supports Linux. So this can be expensive as well. Next is Azure function hosting. You have GitHub examples. You can take them. They are open source and done by people who are enthusiastic about Azure functions, and they want others to learn from their knowledge, so they put their code on GitHub. I would suggest you to go there. You have a special profile on GitHub with Azure, and you can find Azure samples, in Azure samples you can find all the codes, or there is special for this one, Azure function host. So Azure functions are designed to be portable and to be hosted in a variety of places, including Azure Functions service by using resource consumption, premium or app service plan, IoTs. So you have here Azure function host runtime, which can be in development, which is local dev machine, and you can directly connect to your Azure function. Function app delivery can be with the container or with the code directly, and then the operating system you can choose Windows, Mac OS or Linux. And when you are hosting, you are hosting through the Azure service function service, which use your consumption plan, app service plan or premium plan. And then you can choose, with the consumption plan you have code, with the app service plan you have code and container, with premium plan you have code. And operating systems you can choose Windows and Linux. With app service, with Azure function service premium plan you have Windows. Azure functions are designed to be portable and hosted in a variety of places, including Azure services that support containerization, Azure Kubernetes services, Service Fabric, and Azure Container Instances. Non-Azure containers hosts Kubernetes, virtual machines, and cloud providers. On-premises by using app service on Azure Stack. So you can have IoT devices, additional Azure hosts like Azure Kubernetes services, Service Fabric, and non-Azure hosts such as K8, Robbie, virtual machines, or other providers. Premises, app service on Azure Stack. And then delivery of the app can be container and or code, and the and the operating system is Linux for most of them, for less for IT and for non-Azure hosts. And I hope it's clear for you what is Azure Function and how it can be used. Now, the main important part of Azure Function is triggers. A trigger defines how a function is invoked. Azure Function is never it's serverless and it's stateless, and the function is not running all the time. So you have to trigger the function to do some task. A trigger defines how function is invoked. A function must have exactly one trigger. Triggers have associated data, which is usually the payload that triggers the function. So you have a type of service, any service that triggers the function, and then it executes, and then the results are stored somewhere. This is the normal mechanism of Azure Functions, and you can have different type of triggers. There are many type of triggers, such as HTTP trigger, which can be triggered using any HTTP request on internet. Timer trigger, you can execute predefined on let's say batch services, or execute cleanup or other batch tasks on a predefined schedule. GitHub webhook responds to events that occur in GitHub repository. Generic webhook process webhook HTTP request from any service that supports webhooks. Cosmos DB trigger, Azure process Azure Cosmos DB documents when they are added or updated in collection in a NoSQL database. Blob trigger, process Azure storage blob when they are added to containers. You might use this function for image resizing. Queue trigger, how can you use for this function for image resizing? Because let's say you drop an image in a blob, and then you want to resize that image automatically to thumbnail. So you can write a function which resize the image to thumbnail, and you have another thumbnail available for your application. So you can write a small function for that, because if your function is doing some more image processing, then it might take resource of your application. And if you include this thing in your web application, which is stored on app service or web app, Azure web app, then it might consume your resources, and that can be expensive than hosting a Azure function for that, depending on the volume of your application triggers. Then you have queue trigger, which responds to messages that as they arrive in the Azure storage queue. Event hub trigger, which is same as response to events delivered in the Azure event hub. Particularly useful in application instrumentation, user experience, or workflow processing, and IoT. In IoT, it's really important to have event hub triggered Azure functions, which can do some job. Let's say you have an application which sends the temperature of your plants, and then you want to trigger your device sends events to your event hub, and when a new event is queued in the event hub, then your Azure function is triggered, and you do some other some tasks. Let's say you do some calculations, and then you put the output in somewhere, and that output is used to decide if we need to lower the temperature of the plant or not. Service bus queue trigger, connect your code to other service, Azure service or on-premises service by listening to message queues. Service bus topic trigger, connect your code to other Azure service or on-premise services by subscribing to topics. So I hope that's clear how triggers, what are the different trigger types and how it works. Then you have input and output bindings. Of course, as I said, you have an input and you have an output, and an input can be trigger with some payload. So input and output bindings provide a declarative way to connect to data from within your code. Bindings are optional, and Azure function can have multiple input and output bindings. So it can be from multiple input bindings and it can have multiple output bindings. So let's say if you drop a blob storage, it can write the data into SQL database, and at the same time it can trigger or post some to some webhooks. Bindings. Triggers and bindings let you avoid hard coding the details of the services that you are working with. Your function receives the received data, for example, the content of the queue of a queue message in function parameters. You send data, for example, to create a queue message by using the return value of the function. In C# script, alternative ways to send data are out parameters and collector objects. So you can have declarative ways to connect to data from your code, which connects to services without writing the code. Functions can have multiple input and output bindings. Output bindings can send data to Azure services such as storage, Azure Cosmos DB, Azure SQL Data Warehouse, Service Bus, anything. So here are some trigger and binding examples. In this example, the function app is triggered by recurring scheduled nightly and queries. Azure Cosmos DB for a set of documents. The function then processes the documents, outputs blobs to Azure storage, and outputs log to Event Hub. So you have blobs to output Azure storage, and then you write some logs to Event Hub. And again, this Event Hub can be used for another Azure function to do some execution, or you can use, depending on your application, you can use whatever you want to use. Then integrating with Azure Virtual Network. Under the premium plan, it requires premium plan, of course, and Azure Functions has the same hosting capabilities as the web apps in Azure App Service. This means that Azure Functions also has the virtual network integration feature. When virtual network integration is used with the Azure Virtual Network in the same region as your app, it requires you to use a delegated subnet with at least 32 addresses in it. You won't be able to use the subnet for anything else. Outbound calls from your app will be made from the addresses in the delegated subnet. When you use this version of virtual network integration, the calls are made from addresses in your virtual network. So it requires the premium plan, and it secures the inbound HTTP access to your app to one subnet in virtual network. It allows secure outbound calls to resources in virtual network. Let's have an example of virtual network integration. Using addresses in your VNet enables your app to make calls to service endpoint secured services, access resources across Azure Express route connections, access resources in virtual network that you are connected to, access resources across peered connections including express route connections. So it gives you the same functionalities as a virtual network gives to virtual machine. Simply, that's what it means actually. So best practices to have good feasible solutions and economic solutions. We should avoid long-running functions. Large, long-running functions can cause unexpected timeout issues. A function can become large due to many Node.js dependencies. Importing dependencies can also cause increased load times that results in unexpected timeouts. Dependencies are loaded both explicitly and implicitly. A single module loaded by your code may load its own additional modules. So avoid long running functions that run for long time. Cross-function communications, durable functions, and Azure Logic apps are built to manage state transitions and communications between multiple functions. If you're not using durable functions or logic apps to integrate with multiple functions, it is generally best practice to use storage queues for cross-function communication. The main reason is storage queues are less costly and much easier to provision. But another use of storage queues is your function is not overloaded and it will take the request once it's idle, once it's useful. So then you can ignore many problems. Write functions to be stateless. Functions should be stateless and idempotent if possible. Associate any required state information with your data. For example, an order being processed would likely have an associated state member. A function could process an order based on that state while the function itself remains stateless. Write defensive functions and code defensively. Assume that your function could encounter an exception at any time. Design your functions with the ability to continue from a previous fail point during the next execution, so it is not blocked somewhere because of that exception. So now I hope it's clear what is Azure function, how it works. So let's develop an Azure function and using Visual Studio. Azure function tools, function code, bindings, creating an Azure function, project, function app settings. This is what you will learn in this module. Azure function in Visual Studio. Azure Functions is a built-in project type for Visual Studio that lets you develop, test, and deploy C# functions to Azure. So you have a separate type for Visual Studio, which is Azure Functions. The Azure Functions project type provides the benefits such as edit, build, and run functions on your local development computer, publish your Azure Function project directly to Azure, use WebJobs attribute to declare function bindings directly in the C# code instead of maintaining a separate JSON for binding definitions. Develop and deploy precompiled C# functions. Precompiled functions provide a better cold start performance than C# script-based functions. Code your functions in C# while having all the benefits of Visual Studio development. So that's really interesting to use Visual Studio to develop functions. You can also write code directly in the Azure portal and write down this function directly in Azure portal, and you can have this, or you can develop using Visual Studio if you want to have more better functions. Follow rules and regulations and better scalable solutions for future. And if you want to use some libraries, so it's better to do it using Visual Studio as well. Or then you can take advantage of all the Visual Studio functionalities. This C# class represents a queue, basic queue storage triggered function. A binding specific attribute is applied to each binding parameter is supplied to entry point method. The attribute tasks takes the binding information as parameter. In the previous example, the first parameter has a queueTrigger attribute applied, indicating queueTrigger function. The queue name and connection string settings name are passed as parameter to the queueTrigger attribute. So you see here, every function is called run, and you decide the function name in this using this attribute, and you pass queue trigger, which is my queue items, and you pass connection, queue storage, and the string my queue item, and a trace writer log, and simply then you can use all these passed parameters to execute your function. Bindings. Suppose you want to write a new row to Azure table storage. Whenever a new message appears in Azure queue storage, this scenario can be implemented by using an Azure queue storage trigger and Azure table storage output bindings. The first element in the binding array is the queue storage trigger. The type and direction properties identify the trigger. The name property identifies the function parameter that receives the queue message content. The name of the queue to monitor is queue name. And the connection string is the app setting identified by connection. This app setting, which you can add in your Azure function in the properties, this connection is identified with this my app storage app settings. The second element in the bindings array is Azure table storage output bindings. The type and direction properties identify the bindings. The name property specifies how the function provides the new table row, in this case by using the function return value. The name of the table is table name, and the connection string is the app setting identified by connection. So you have direction is out, here it was in, and the table name is out table, here queue name was my queue items, and connection was my storage app settings, my table storage app settings. So that's how you can define bindings. The value of the connection is the name of an app setting that contains this connection string, not the connection string itself. Bindings use connection string stored in the app settings to enforce the best practice that function.json does not contain service secret. So the app setting here, it's defined, it's not directly the connection string, but the connection string defined within this variable or this app setting, my table storage app setting. And now binding based code. So you say here C# code that works with this trigger and binding. Notice that the name of the parameter that provides the queue message content is order. This is required because the name property value in function.js is order. The method takes an incoming, let me just show you. Here the incoming binding was, the name was order. So here now we call this JObject as order. The method takes an incoming queue message that is a JSON object and then add fields and write to table storage. The method return value creates a new row in table storage. So you see a new person blah blah blah, and then it returns this thing, and then the output is stored in this table. Now let's do it. And in this demo we should create an Azure function project, creating a function, add bindings to the Azure function, and testing and publishing the Azure function. So what do we need for this? We need creating an Azure function project, creating a function, add bindings to Azure function. Let's go. So to create, let's go to Visual Studio. and Visual Studio has already defined a template for Azure Functions. So in this, while creating a function, I just need to type and search for that template. It goes here. It found the Azure function template. You have Azure Stream Analytics application, Stream Analytics application. You have other Azure applications as well. Azure Web Job, Azure Cloud Services, Azure Resource Group. You have many projects template you can create, and I'll call the sample 20 is a 203 function, and okay, now I want to create. Okay, and now it is asking what type of trigger I want, because as we discussed already, you have a different type of triggers here. All the triggers are there. So let's say HTTP trigger, because it will be easy to test. Otherwise, for other triggers, I have to upload, do something with some database, blob, event, grid, and I have to configure all those things as well. So let's go with HTTP trigger, and you see here you have a storage emulator, which is inbuilt thing for Azure. If you have your own storage account, you can create, you can use that one. You can browse it. I don't have any, so I will go with HTTP trigger and storage. Now it should create a HTTP trigger function with with the trigger type, and so if you see here, it has all these things. Okay, it is just showing me that you see it created a function called function name, and the function type is get, function get post, root is null, predefined C# HTTP trigger function processed a request for the log information. In the request you will get the query, the name, and and you see here deserialized response message, and then you can return the OK result. So you see it's pretty simple, like a console application. And in here as well you have not many things, just a function.cs, and you have host.json, which is containing for the logging, application insights, sampling, exclude type request, sampling settings. So you can have, as you discussed, a JSON file with different uh, different things, different settings. Azure Web Storage, use development storage true. If I have chosen the Azure storage from my own storage from Azure, it would have the link to that. And now, simple. I let me just run this, and it's just starting the emulator for storage. Okay, it is doing something. It is taking some time for to start the storage emulator, but it's not a problem. And what it will do, it will just run on localhost. So you see here it said started emulator. and now you see just gave me every detail about my function which I just created with my settings I used, and my function is ready to use on this port. So if I just go to http localhost 7071 API function 1, it should say something. So let's go to that. Localhost 7071 and then it was API function 1. Just arrived here and it's just checking for it. Log information, because I did not send any name in the query, so it's null. And let's go. Data is null, and so the name is null, and my string will be null now. So what is response message? HTTP trigger function executor especially pass a name in the query string, which I say the message here, and then so you see it is responding. This HTTP trigger function executed successfully pass a name in the query string or in the request body for a personalized response. So if you say like here name equals to track of the day, and let's go hello tag of the day, the HTTP triggered function executed successfully. If you see the response, so that's all, and you have your function up and running now. So let's stop it now. Now what we need to publish this function. So to pick up a publish target, we need to create Azure function app in the Azure cloud environment, and then with the new function app with the related resource so once we have created the function app, then we can pick up a publishing target. So if I just click here and publish, so it is asking me create new plan and type of plan. You see here you have different type of Azure function consumption plan, function premium plan, service plan, and another one. So let's create with this one. And it is I don't know if you can see it, but it just gave me the name, resource group. It selected the already built resource group, but I can create new one, but it's okay. Location, I can change the location to North Europe. And Azure storage, it will create a new Azure storage for me with this, and that's all. So you see all the possibilities here, and now I can create my new Azure function here. So create, so your function is up and running here, function 1. You can also get the function URL from here, and you can just copy it, and you will see it's running here. Tech of the day, I just put the name here, and that's up and running. So as our function is up and running now, I will clean up the resources. Let's go. I'll just drop all the resources here. So I'll just go there and I will check for my resource groups, because I don't need to keep them up and running all the time. And I will also remove this one. Okay, so now it will keep deleting my resources. It will take some time. So as we are done with the creating Azure function project, let's so this was just this was the last thing we had. Okay, now we need to develop, implement durable functions. So functions, Azure functions and durable functions. There is a difference between Azure functions and durable functions. I will discuss them here. In this lesson, we will cover durable functions, creating durable function in C#, fan out, fan in durable functions. So let's go. Durable function is an extension of Azure Function and Azure Web Jobs that lets you write stateful functions in a serverless environment. The extension manages state, checkpoints, and restarts for you. The extension lets you define stateful workflows in a new type of function called orchestrator function. Here are some advantages, like they define workflow in code, no JSON schemas or designers are needed. They can call other functions synchronously and asynchronously. Output function Output from called function can be saved to local variables. They can call other functions synchronously and asynchronously. They automatically checkpoint their progress whenever the function awaits. Local state is never lost if the process recycles or the virtual machine reboots. So durable function is an advanced extension for Azure Functions that is not appropriate for all applications. The rest of this section assumes that you have a strong familiarity with Azure Function, as we just talked. So the primary use case of durable function is simplifying complex stateful coordination problems in serverless applications. The application pattern that can benefit from durable functions. There are typical application patterns. So durable function scenarios. Function chaining refers to pattern executing a sequence of functions in a particular order. Often the output of the one function needs to be applied to the input of the another function, so which is like chaining. So we have a scenario here. The value f1, f2, f3 are the name of the other functions in the function app. Control flow is implemented by using normal imperative coding constructs. That is, code executes top down and can involve existing language control flow semantics like conditional and loops. Error handling logic can be included in try and catch finally blocks. The CTX parameter, durable orchestration context, provides method for invoking other functions by name, passing parameters, and returning function output. Each time the code calls awaits the durable function framework checkpoints the progress of the current function instance. If the process or VM recycles midway through the execution, the function instance resumes from the previous await call. We will cover this restart behavior later. So you see you have four functions in the same durable orchestration context, and you call these activities f1, f2, f3, and you can handle the exceptions. Fan out, fan in refers to the pattern of executing multiple functions in parallel and then waiting for all to finish. Often some aggregation work is done on results returned from the functions. With normal function, fanning out can be done by having the function send multiple messages to a queue. However, fanning back is much more challenging. You would have to write code to track when the queue triggered function and and store function outputs. The durable functions extension handles this pattern with relatively simple code. So you have function 1 and then you have function 2, which is fed by function 1 and f3, and it can be in a loop here. So scenario, where can you use fan in fan out code? The fan out work is distributed to multiple instances of function f2 and work is tracked by using a dynamic list of tasks. The .NET task.fan all API is called to wait for all the called functions to finish. Then f2 function outputs the aggregated form of dynamic task list and passed on to the function f3. The automatic checkpointing that happens at the await call of task.when all ensures that any crash or reboot midway through does not require a restart of any already completed task. So let's say if you are executing F1 and then meanwhile you are executing F2, the VM restarts. So this makes sure that you don't lose your pre-done work. So another scenario where you use async HTTP APIs. The third pattern is all about the problem of coordinating the state of long-running operations with external clients. A common way to implement this pattern is by having the long-running action triggered by HTTP call and then redirecting the clients to a status endpoint that they can poll to learn when the operation completes. Durable functions provide built-in APIs that simplify the code you write for interacting with long-running functions and executions. After an instance is started, the extension exposes webhook HTTP APIs that query the orchestrator function status. The example shows the REST commands to start an orchestrator and query its status. For clarity and some details are omitted. So you see, you have this start and it does some work in the loop, and then if you want to get the status, you can query this. So what type of responses you might get, because the state is managed by durable function runtime, you don't have to implement your own status tracking management. And the status you get when you say curl exposed to this function, blah blah blah, this ID, and this type of response you might have. So it says running, last updated time was this, and then you have completed, last running updated time was this. And now we have durable function scenario, async HTTP APIs code. Even though the durable function extensions has built-in webhooks for managing long-running orchestrations, you can implement this pattern yourself by using your own function triggers such as HTTP, queue, or event hub, and orchestration client binding. For example, you could use a queue message to trigger termination, or you could use an HTTP trigger protected by Azure Active Directory authentication policy instead of built-in webhook that use a generated key for authentication. The durable orchestration client starter parameter is value from the orchestration client output binding. which is part of durable function extension. It provides method for starting, sending events to terminating, and querying for new or existing orchestrator function instance. In the previous example, an HTTP triggered function takes in function name value from the incoming URL and passes that value to start new async. This binding API then returns a response that contains a location header and additional information about the instance that can later be used to look up the status of the started instance or terminate it. So here you had in the response, you had this information with an ID. You can use it later on. Here start new async, and then in the response you can use that instance ID to check the status. A durable function monitoring. The monitor pattern refers to a flexible recurring process in a workflow. For example, polling until certain conditions are met. A regular timer trigger can address a simple scenario such as periodic cleanup job, but its interval is static and managing instance lifetime becomes complex. Durable functions enable flexible recurrence intervals, task lifetime management, and the ability to create multiple monitor processes from a single orchestration. An example would be reversing the earlier async HTTP API scenario. Instead of exposing an endpoint for external client to monitor a long-running operation, the long-running monitor consumes an external endpoint waiting for some state change. So you can have your own monitoring endpoint to check the status. So to durable function scenario monitoring code, when a request is received, a new orchestration instance is created for that job ID. The instance polls a status until a condition is met and the loop is exited. So if the current UTC date time is less than expiry time, then it will keep continuing the job, and further work can be performed or orchestration can end. When the ctx.currentUTC date time exceeds the expiry date, the monitor ends. Simple. You see here you have ctx, which you pass a durable orchestration context, and then you have an expiry date. You just get this expiry date from somewhere, and you check with the time. If it's less than that, keep running, and after that it stops. And you can have human interaction scenario. Many processes involve some kind of human interaction. The tricky thing about involving humans in an automated process is that people are not always as highly available and responsive as cloud services. Automated process must allow for this, and they often do so by using timeouts and compensation logic. One example of business process that involves human interaction is an approval process. For example, approval from manager might be required for an expense report that exceeds certain amount. If the manager does not approve within 72 hours, maybe the manager went on vacations, and escalation process starts to get the approval from someone else, perhaps the manager's manager. So here you have a request approval, and then you have a timer. If it is not approved, then it will start doing some other logic, whatever you configure here. So that's really interesting. Of course, you don't want to have human interaction in automated processes, but if you have to, then you can do that. So durable function human interaction scenario code will look like this. The durable timer is created by calling ctx.createTimer. The notification is received by wait for the external event and task when any is called to decide whether to escalate. Timeout happens first or process approval. Approval is received before timeout. So you see here you have this ctx and call activity to request approval. Then it keeps checking if timeout occurs, and then it checks if process if you need to do the process approval by someone else, and then call activity escalate. This is just an example. It would of course differ in your case, so you might have some different scenarios. Durable function scenario with human interaction code, and there might be also, if it's approved, raise event async approval event is approved. So you see here, you keep waiting for that. An external client can deliver the event notification to a waiting orchestrator function by using either built-in HTTP APIs or by using durable orchestration client dot raise event async API from another function. So you can wait for this from another function. So let's create a durable function in C#. In this demo, we will create a durable function by using Azure Functions extension for Visual Studio Code, create a starter function, orchestration function, and various activity functions, deploy and validate the function in Azure. So now let's create a durable function. For that, we simply create a function, project, Azure Functions, next, Azure durable function, and now it asks me create. We're gonna create an empty function, and storage emulator, yes, then create. Now it just created an empty function for me. So what I need to do is I need to add a new Azure function now. Add new Azure function, and in here and now I need to search for durable function. Need to name it up. Whatever, testing. And now I need to select the durable functions orchestration. Okay. So now you see here I have a function named this, and hello with the name of the durable activity, blah blah. These are the function called activity async, and now we can say hello. You see you have HTTP start in here, you have start async. So I'll just start it and see what happens. Because if you see here, you have function names, you have multiple functions in here, and yeah, you have a testing function name, then you have testing hello, you have testing http start. So you have multiple functions here. Up, I would say we need to recollect our just what we talked, and you need to see that. So your application is up and running now, your function is up and running now, and you can go to this 7071 API testing http start. So let's do that. 7071, it's already there, API, and I can say, what is my function name, what is my function name is, I can go there and see my function is API testing http start, testing dash http start. Okay, up. Did I do? I always do typing mistakes. Okay, so it called testing http start now, and if you just go through it, it created an instance ID. You have the instance ID now, and with the help of this instance ID, the orchestrator knows this ID, and now create a status response. You have the status response now, and this orchestrator is run against this, and now you have the response, and it will keep running for just to check, keep checking. You see, up. I just need to stop this breakpoint, remove this breakpoint, and let's see what is the status. You see, the status will be run every time. Durable task instance this, task hub, task connection storage this. So you get all the information about it now, and it will keep running. And now if you want to get the status query URI, you can copy this and you can check the status. So I hope it's clear how does it work. Let's publish this. I can publish this to Azure the same way I did for Azure Functions. So I will do like this, go publish, and same way create new, create profile, and the source group location is Azure storage is empty. That's a bug, I guess, because I'm not able to select it does not create a new one, so I have to do it here. I have to create a storage account, and then I can use that storage account for me. Storage account, and that is used by default by my Azure function if it will detect that I have something. Okay, AZ-203 durable function, and now I have my storage account, I guess. AZ-203 durable function in Northwest Europe with this all this. Okay, I go to networking because I can have networking, but public endpoint all networks, I allow this one for the moment. Up, then you have Azure files here, secure transfer. Okay, now create Now my storage account is will be created. Then I can have this storage account in my Visual Studio here, because if I try directly like this, because you see here it should have a location, but it does not have, so I will have an exception. Oops, this time, yeah, you see I have exception. The value of deployment parameter Azure durable function storage account location is null, and that's true because here that's maybe the bug, but it did not get the location. And if I try to do it like this, select location and say OK, then it does not let me create it. So I created my own storage account. It's ready now, and I should have it now here. If I just go create profile, and now it should select the Azure durable function storage account for me. And now if I create, boom, it should be fine. So what we just did, we just created an empty Azure function, and then we added ourselves Azure function with the property durable orchestration context, so which is durable function. And in that function we have three by default created methods, which is http starts, one is any just function, and another one is context one, and that is continuously running. So that's the benefit of having durable functions, which can run longer. This one is taking it's really long, so let's go to this account. Let's go to resource groups and see what do we have as. Okay, this resource group is there, storage account is there, and we are waiting for our durable function to be created. I'll pause it for a moment and we'll be back. Okay, it's done. So you see it's here. If I just copy this and go there, I should have the durable function up and running, like this. So you see use Azure Function 2.0 app is up and running. And now if I want to test it the same way I did for Azure Functions, I can do it. And I can also go to my Azure function here, durable Azure function here, and see what is there. Up all resources I just created with durable. Yep, I just created this one. So, and here you see that's up and running, and it is just loading the functions it has. It should have three functions actually. What we have here: testing, hello, testing, http start. So it should have these functions. Okay. Okay. Oh yeah, because I did not publish it yet. So it's say now it's time to load your. So now I need to publish this code. It will take some time as well. Shit, I just forgot to do it. Yes. Let's wait for a few seconds. Cannot really wait for this. Okay, let's go here. Let's see what do we have up. Okay, functions read only, not done yet. Yes, still working. So but what I have here is so I created a Azure function username and then with this password. So what I will need to generate a URL with the specific code as we did for this one. So you see here API function name tech blah blah blah, then you have this code from here till here, and that is the generated code which which is used to authenticate you. Now the function I deleted it, so it's not there yet. Okay, and now let's see if the function is it's still publishing, so it takes some time. Okay, but I hope it's clear and the difference between Azure functions and durable functions. Where should you use Azure functions and where should you use durable functions, and how you can do that. So using Visual Studio or Visual Studio Code, you can easily do it. You have the template Azure function. For normal function, you can just type in and you do that. Okay, it's done now. So if I just refresh it should have those functions. So for normal function, Azure function, you just need to use that template and you can modify. It will just create for you a function, Azure function. And for durable functions, you need to create an empty function, and then you can add you can add durable function there by adding new function. So you see here you have three functions in it: testing, testing hello, testing http start. And here you see you can run this function. You can integrate this function somewhere else. You can manage. So you see master default. You can do many things. It's the same like so if I just say run, it's up and running. Okay, up. If I say testing http start, and get function URL from here, I copy this, paste it here. Up, my app is up and my function is up and running, and I have the same output like I had here. And now I can check the get status query URL, which is this one, and I can check it anytime I want to see my status. Okay, and this API URL is still up till here. So if I just copy this and call this, so you see you have the status, the instance ID, runtime stats, completed, input null, custom states, hello Tokyo, hello Seattle, hello London, created time, last updated time. Because here in our code we had it's calling testing hello the function, and it's calling with the Tokyo, Seattle and London, and then this function testing hello receiving this value string name and saying hello to Tokyo, saying hello to blah blah, and then you return this. So you see this message here, that means it is called three times: hello Tokyo, hello Seattle, hello London. So that's how you can create Azure durable functions. I hope it's clear, and if it's not, please let me know in the comment sections. Now I don't need to do a web application on Azure Platform as a service offering. Yeah, we will do a different video for that, because this video is already too long. And let's cover up in the review what we did. We created Azure function, develop Azure function by using Visual Studio, implement durable functions, and we did not do any lab. We will do in a separate video. So thanks for watching, and I hope you liked it. If you have any question, please let me know in the comment sections below. And if you need to know something about durable functions or Azure functions, please let me know also in the comment section below. Thanks. Have a nice day.